This is our first live structural modeling hangout for the structural modeling project. And we've done a couple of test runs on this, and now we're going to do our first inaugural real live Google on the air broadcast. The agenda for this particular broadcast, we're going to go over the general approach and what we're going to what we've been doing in the project, what we are going to be accomplishing, what our objectives are, and then highlight some of the activities that have already been performed, go over some of the material, highlights of the material that were presented at some conferences this summer, and then we'll also talk just a little bit about a presentation that will be given later on this month at the Seattle chapter of NCOSE. So, as it shows here in our general approach for our structural modeling project, we'll be talking about two constructs that we've developed to address complex system structural problems. And those two constructs are the abstract relation type and the augmented model exchange isomorphism. We developed these two constructs and concepts to be able to talk specifically about the different types of information and the arrangements of information that are required to engage and talk about large-scale complex systems. So let's see. This morning we have a few people online. I see that we have Thomas and Mary and Kevin, and we have a few. We expect maybe a few more. Janet and Constantina are on travel, so they've already indicated that they won't be making this meeting, but they'll be making the other ones. So we use the ART form and the AMEI to collect information about complex systems, and we use that then to create a structured approach for presenting the information. When we have gone through this activity of analyzing different approaches from various groups, what we found is that the logical property of symmetry appears to be the best way to organize our mathematical prose and structured graphics. So I'm going to just bring up a new graphic here. Hopefully, let's see. I'll bring this over. There we go. Now I'll see if I can. Doesn't appear to be sharing it yet. Try to screen share. Okay, so, oh no. There we go. Get the screen share. All right, then the one we want to share is this one right here. Yeah, share this one. All right. So everybody might be familiar with this particular graphic. I think it's a core concept that we've actually developed in looking at these different approaches. And the organizing property of symmetry really seems to be a strong discriminator for our approaches. What we've been doing in the cities problem, in ordering the cities, and in working with the total ordering, and even now the work we're doing with the partial ordering, it's been over here using an asymmetric logical property, and it basically creates a hierarchy. And there's strong deductive logical powers that can be used here to address complexity. This is a deterministic approach over here in the asymmetric column. And then on the symmetric side, where we have the networks, we have things that are symmetrically connected within a system. We're using clustering and genetic algorithms and evolutionary computation basically to find best value type of solutions. These types of solutions are non-deterministic right now, and what they do is they help groups of people navigate through extremely complex sets of permutations and combinations, looking for combinations of system components that may be more valuable than others. And then in between, we have the combined hierarchy and network. Warfield, in his binary matrix publications, addressed these. This seems to be this seems to be the approach that's used by many people, but it's not really. It's not really. Yeah. So this particular approach seems to be the one in the middle, the non-symmetric approach, seems to be used by most people, but it's not really clear what the distinction is. So what we're doing is we're really trying to put together a clear approach, clear manner to make a distinction between these. And that's kind of where we are right now. And we've been working on the hierarchy side where we did a total ordering of the 19 cities problem. And now we're working on the partial ordering of the 19 cities problem. And that material is available on the System Concepts website. So I could bring that up and show people where that is. So far, is there any questions so far? Okay.
Joe, why? It seems like the diagram you've listed for the non-symmetric case could be generated by some combination of answers to an asymmetric question.
Right. It's there. That's really a good point, Kevin. And I think the one of the key aspects of this, and it's kind of at a little bit deeper level, is the idea that every question, every natural language relationship question is going to have these properties. And in natural language, we're not really clear, and we don't really, we don't really make this distinction in natural language types of relationships. So when you're going into the questioning and you're going into the group information and group input mode, that has to be looked at and really, addressed carefully. So it's it's something right now that we're going to have to work on later on as to actually how this is implemented so that we can make the best transition from the natural language information that we're getting from the groups of people to the mathematics and the structured graphics. But that's really a good point, Kevin. Okay. So the other part that we're looking at here, as I said, we're basically working with a hierarchy. That's what we've done with the 19 cities, both the total order and the partial order. It appears to me that the work that Konstantina is doing is in this center area here where things are not that well defined. And then our evolutionary computation work that we've done with other clustering mechanisms in our published work is over here in the network area. And right now the plan is to finish the hierarchy work, upgrade and add some additional methods to our network piece, and then start addressing this center combination piece. So it will be interesting to see how that goes. Okay, so now we're going to look at the methods and mechanisms that we use to put these together, make them work.
Pardon me for interrupting, Joe, but
Sure.
Kevin Dye got cut off and he's having trouble reconnecting.
Okay.
And Alexander tried to join and was unable to. It just created his own hangout.
Okay. Let me then try to invite them again. Do this. Okay, there's Alexander. Now we'll get Kevin. That's what happens when we try these new things. We'll have some problems until they get worked out. We have Kevin back. Okay. Here we go. I'll invite Alexander again. You can get online. Okay. There we are. Looks like have Kevin back, but Alexander's not online yet, so I'll try to invite him from time to time and see if you can get connected. But if not, this will be, again, this broadcast will be on YouTube. This is our first attempt at this, and the idea is with this on YouTube, people can, over the period of time between now and next month and our next monthly meeting, if you have questions or so forth, we can start a conversation or a correspondence about those questions and then address them at the next meeting. So essentially we're using right now this properties of symmetry to organize our major macro activities. And for the activity that currently the one that I'm working on is the transition of the total ordering of the cities problem, which I did in JavaScript, and moving that over to a partial ordering using JavaScript. And I picked a new approach and a new library for the work that I'm doing with JavaScript. So let me just kind of bring that up and let people see that and what it looks like. So let's see. Here we go. There we have Kevin back. Kevin, you seem to be dropping in and out.
Yeah.
So okay, it's a new thing. They changed the interface yet again this month, and it took me 15 minutes this morning to figure out how to hook this thing up because they changed it differently. So it still is not quite stable yet. So we get for being on the cutting edge of things, I guess. Okay. Well, so anyway, I've chosen ZebKit, which is a canvas that really is going to, I think, help with the ordering of the and management of the JavaScript graphics that are necessary. And all I need to do right now is figure out how I can bring this thing up and show it to the rest of the group on the screen. Might take me a minute here or so, because again, it seems to be a little different configuration this time around than it was last time. You wouldn't want to keep it exactly the same, because then people would know how to work it. So let's see here. Where are we? Try it again. Okay, here we are. All right, now let's see. Can people see that new screen?
Yes.
Okay. Now this is just my test mode that I've been working with, and if you remember the last one that we were doing with the 19 cities, we had a one-to-one relationship between the latitude that the city was at and the city itself, and there can only be one city at each latitude. So the latitudes were totally ordered, and we just substituted actually the city name as a representation of that latitude, and then we ordered them that way. So in this approach, we have the 19 cities, and we allow the more than one city at each latitude. So what that means is there's no longer a one-to-one relationship, but we're still going to use the total ordering of the latitudes for a mathematical approach, but we're just going to group more than one city at each level. And what that means then is we really have to have the ability to change the size of the matrix dynamically and generate new vectors and so forth dynamically as we're working with the JavaScript. And this is a little different than the one we did last time. Last time we had a 19 by 19 grid all the way through, and we were just doing the mathematics on it. So I've chosen this particular kit because it really helps drawing things on a canvas, and we can also change things dynamically as we go through. So here I'm going to initialize the city grid like we did in the last one. And as we can see, I did a 20 by 20 city grid here, and that draws that. And this graphic configuration is different than the older style, because it's all done on one canvas. It's not done on 3 canvases, and it's integrated carefully. And then we're going to ask a number of questions. One more question than we did last time. Last time we asked if a city A was north of city B. When we asked that question, if it was no, then we knew, because of the asymmetry, then the city was south. And we really didn't allow them to be at the same level, so we didn't need to gather any more information. So in this particular case, we allow them to be at the same level, so we have to ask that question. So if they're at the same level, right, then the first thing we're going to have to do when we enter the data is we're going to have to generate a smaller matrix, because we're going to take those two cities and we're going to combine them into one row and column. So in this case, we went from a 20 by 20 matrix down to a 19 by 19. And this is as far as I've gotten with this particular approach, but just wanted to show that essentially we're using a different JavaScript kit, and this is kind of the idea. And it also allows us to really generate quickly different sizes of matrices. We can do smaller ones, and enter the information. And hopefully by this time next month we will have a more complete, maybe even a complete example that we can show what's going on with this. So that's where we are with the software component on that. And
Wanted to interrupt one more time.
yeah,
Alexander did receive the second invitation, but it
yeah,
again created a new hangout where he was supposed to invite other people. So he's gone
yeah,
ahead and gone offline.
oh, okay. It's yeah. There's something there's something that's not quite right with that. I'll try to work with Alexander maybe later on during the month and see if we can get the hangout thing figured out for him. Okay. So we've got the structural components. Let's go ahead and start resharing here. Let's screen share on this. All right, let's share the screen. Okay. So let's go back and look at the general approach again. Now that we've looked at the AMEI and the abstract relation type a little bit more. Oh, come on, wait a minute. It's not quite right. So let's try this. There we go. Let's try this one. Should be readable.
That's much better.
Okay. So let's just kind of walk through this a little bit and highlight some of the things that I think I've already said. So basically what I said is there's not been a strict separation between the collection and mapping of these natural language relationships. And I think that's what Kevin pointed out also. And even if we develop these well-defined transforms in the structured graphics in the mathematics, it's still going to take a careful work to create the methods and the processes to translate that from human group language into these more structured interfaces. And really what I think one of the primary values of this is we will cycle that back in a feedback loop, in a tight feedback loop, and work it back into the and help the group with the immediate feedback from the graphics and the mathematics to see whether or not their natural language utilization is consistent. And there should be a number of structured ways that can help normalize that interface. So then again, as I've said, we've used the properties of symmetry to create 3 general categories of approaches, which we find are fairly, so far anyway, they've been good at defining the boundaries between significantly different types of approaches, and have allowed us a way to actually look at classical approaches and to discuss them, take them apart, and categorize them so that we can see what the differences are, and also then, hopefully in the future, what we hope to do with these is be able to create mechanisms where we can integrate them and use the best approach for the given situation. So that's going to be another kind of aspect of this as it goes forward. And so the influences natural language relationship, which is being used by the folks at the Future World Center, appears to use, to allow both the symmetric and the asymmetric connections. And we haven't looked at that in much detail. I think there's some general approaches that kind of might be promising. I'm not sure that what those are going to be, but it looks like there'll be some ways to handle that and to integrate these two ways forward. So is there any questions on that part?
Yeah, Joe.
Yeah.
Suppose you have two elements, two nodes,
Mm-hmm.
A and B.
Mm-hmm.
What's the difference between there being a symmetric relationship between A and B and there being an asymmetric one from A to B and an asymmetric from B to A?
Yeah, that's really a good question. And when we look at the representation, right? So that type of detail and that type of understanding of the question, if we think about the different languages that we are using to talk about the abstract relation type, to talk about these relations, in the prose, in the natural language prose, we really would have difficulty being able to make that distinction. We'd have to go through some fairly verbose discussions to do that.
I think it may be difficult to make the distinction after the relations have been asserted, but to me the difference is the symmetric relationship could be asserted with the yes or no to the answer of a single question, and the asymmetric relationships, you have four potential answers to two yes or no questions. But in one case, if they're both yes, it happens to be a symmetric. It results in a symmetric relation.
Yes.
Well,
Yeah.
it looks
Let's.
like a symmetric relation, but it's represented by two different relations.
Okay. So I guess the pathway that I was going down, and I agree with your general approach. The pathway I was going down is to talk about the expressive power of the three different isomorphic forms of language, and so that yes, you could do it in prose but a number of questions, but it would be very clear in structured graphics or in a mathematic matrix form, because if you look at a mathematical matrix in the square matrix, you really only have the A to B. And so you have the A to B mark, and then you have the B to A mark. So that marking space on the matrix is very helpful, and so that would show a graphical icon of the prose situation that you're talking about. And so you could take the permutations that you're talking about in these relations, and then you could have a distinct graphical matrix icon that represented each one of those. Does that make sense?
I mean, I think another distinction is if you're inquiring about whether a symmetric relation exists or not, you only need an upper triangular or lower triangular matrix.
Aha, okay, that's another way of putting it, right? Because you know what?
Because you're asserting both ways from one bit of information, so you only need one cell to assert or deny a symmetric relation.
Okay, now that's really a good statement. And what you said is you need just half of the matrix. You need the yeah, and it's
or you can do it with the full matrix, but you would enter, if you ask about a symmetric relation, you'd enter both of them in at the same time if it's true.
Well, that's absolutely correct, and the reason and this area. Okay, let me kind of set a little bit of context here. And so what you're talking about is where you start with no information about the scenario. And what we have done when we do that, we have the complete matrix, and we have worked with asymmetric type of relationships. We haven't worked with the symmetric relationships for a couple of reasons. One of them is this idea of the self-interaction, half lower triangular or upper triangular matrix. And in many cases, they allow both. They allow symmetric, and then they also allow asymmetric relationships on using the lower triangular. And I'm not quite sure that there's enough expressive power in that approach where you allow them both to actually complete the process. But when, again, we're starting with no information, and we start to build that up and add information, and we have only done that with an asymmetric relationship. When we've worked with, in the past, when we've worked with the symmetric relationships, what we do is we start with the total information. We know how the system is connected. We know all of the relationships in the system connection, but what we don't know is the highest value configuration for that symmetric connection. And so what you're talking about, which is developing from no information about the system and developing the complete set of data about that particular structure, we really haven't focused on yet. And I haven't focused on that because I found a number of things that simply appear to me not to work out. And so that's why I have started on the two sides. I started with the evolutionary computation on the symmetric side, with the initial conditions of knowing all the connections and then just looking for the highest value configuration. And on the asymmetric side, I've started with a condition of, okay, we really have no information about the system, and we are developing it with the least amount of effort. And what you're talking about is two areas that are similar but different, and we haven't addressed those yet, but they need to be addressed. And I think there's some solutions to that, but I think those solutions are going to be facilitated by specific applications of techniques that are valuable in the asymmetric side, and techniques that are also valuable in the symmetric side. But I'm just, I haven't got to doing that yet. But it's really important. Just not there.
It occurs to me that along with the ART and the AMEI, there seems to be the need for a kind of a state space of the inquiry, the state of the inquiry, and the approach to the inquiry.
All right. Okay. All right. Well, let's see. So we go all the way back, right? Let's go all the way back to the first systems charts that Warfield published in the IEEE and the SMC and other places. That's essentially, um, you could interpret what he was doing as a machine state space where he had a combination of matrices and also transition triangles, the lower triangular or upper triangular. And there was a whole series of these that you went through. And each one of those transitions within the subsystems, within the general global system state space, um, addressed one kind of transition within the system. And that's, I believe, the work that he did at the Mitsubishi shipyard, and that they then translated into the House of Quality or whatever, and lost the logical connections and lost the logical inference on it. Are you familiar with that work?
I am, but I'm not following you with it related to, like, that's what I'm talking about is the difference between what information we already have,
Right.
what information we're looking for, and which way we ask the question. And we don't really have a model for that. There's an algorithm in the ISM algorithms that decides what do we look for next. But I don't remember seeing, well, I mean, there was a number of things that were not formalized; they were just done. But like, it was the. It seems like there's a need for something that follows the dynamic of the information gathering.
Yes. Well, so there's let's see how to say this. I think there's three components here. One of them is the human experts, the human group, the people that are thinking and providing the information and are doing the analysis. The other is the process that's used to help these people overcome some of their natural barriers and natural constraints to dealing with large-scale systems. And then the third part is the mechanism, is simply the mathematics, the language, the prose, and the structured graphics. And one of the things that's clearly not involved with what we're doing yet, but what needs to happen is to be able to either map the development of this information by the group in a single thread, or to have multiple threads that are going on basically in the background, being computed in some way and saying, well, what if this is in error, right? So the group said this, but what if that actually is not true? And given the information that the group has, or given the information that the system has, they could calculate parallel threads, and that could either be monitored or you could ask feedback questions on it. There's a number of different things that could happen there, but that's a little more advanced state really than where we are right now. Right now, what we're working on is just the component parts and the overall global controller for the whole state. There's a number of ways that could happen. Any more comments or questions?
Yeah, for example, one way of filling out this matrix is as you've presented it. You present the matrix, and then people can assert yes or no answers into different cells of the matrix.
Right.
And another way is you have an algorithm decide which pairwise question to ask for information about.
Right.
And then another way is to allow people for what I observe when we do this work. we often want to override the algorithm because people often have pairwise relationships they want to strongly assert.
Right?
They might be wrong, but they believe it.
Yes.
And they might want to revisit it later, but so they're like in the first version of the Cognoscope, you could just pick the two things you want to assert a relationship between
Mm-hmm.
and enter it and just override the algorithm. And
Yeah.
we don't really have some model of the inquiry that accounts for these distinctions in the path of inquiry.
Ah, okay.
And one of the reasons I think that's of interest is because when you, I think one of the big breakthroughs to look at is distributed ISM,
Exactly.
right? So
Yep.
the inquiry is path dependent, right? So if it, based on what you've entered in the matrix, you end up with spaces that are, you don't know much about, and if you had answers to some of them, it would give you more information than if you answered other things in completing the matrix. But if you change one step from someone, say someone said, I really want to assert this relationship, and someone else just lets an algorithm run, and a third person just going through the matrices on their own accord. They all have different paths, and they end up with generating different series of questions, and then they're changing which pairwise relations they're asserting versus which ones are being inferred. And we haven't really seen much of a discussion of the distinction between different modes of using this.
Yes. I think there's a couple of important points. And I think one, that fellow from Portland State University where did the review by in the early 80s. I think what he did was he commented on this idea of a sequence of which elements are picked first and which elements are, put off for later, and how that inference works. I think he gave some examples of how that actually happens and how it changes the answer. But I don't think that happens in a deterministic system where, let's say, ordering the cities in an asymmetric form. You're not going to change the answer of the order of the cities because we know what they are, right? We're just trying to...
What if you don't know what they are?
What now?
What if you don't really know what they are and you have a bunch of people guessing, and sometimes they might be wrong?
Right. Okay. So now, if you have that's a little bit different classification of problem. And so, if there's error in your sensors, so the people really don't know what the answer is, and they're trying to come up with some possible answer, right? So you're going to have a fairly wide variation in that. And again, that fellow at Portland State worked that. Also, that's one of the problems, I believe, that's associated with the binary functions and the binary relations that we're working with here. Really, the transitive property within the relationship, even though there's two items being related within the relationship, if it's a transitive property, then it allows basically a trinary relation. And I have some, well, it's my inclination now to believe that actually a trinary type of relationship, similar way of analyzing any given problem that you're looking for, it needs to be developed. And can't see much more than that right now, but hopefully I'll be able to work out some examples as we go forward. And so basically what the idea is to use the highly developed aspects we have right now, the binary relationships, and determine if there are any trinary relationships that are situationally dependent or problem dependent or category dependent that will allow us to address these things that you're talking about. Because it'll be like a generative function. The trinary relationship itself will give us a way to generate then different information sets instead of just following the binary relation. So yes, it's an issue. These are all good points, Kevin. And there's a lot of work to be done in this area. So I'm just going through it a step at a time and working on the basic components. And the idea, of course, is to hopefully create a foundation of components and modules that can be used to address these more or different types of problems that you're talking about. But they're all documented in the literature, and they're all actually valid. So I really really don't know. It'll be interesting to think about that and see what do you think? What do you think a good approach would be?
I don't know.
Okay, so we'll just kind of go forward and see what we can find.
I think I'm just suggesting that along with the abstract relation type and the augmented model exchange isomorphism,
Yeah.
that I think there's another component there which tracks kind of the state of confidence of the knowledge that is being asserted compared to what if there's such a thing as a reality, an objective reality is a metric.
Yeah.
What it is, something about that accommodates the chosen path of inquiry.
Okay.
You could choose to redundantly enter every cell of the matrix, and then see which ones conflict with transitive inference.
Yeah. Okay. So that's what I mean by multiple pathways, right? You could do that, and then you could check different logic forms, but you could do that in parallel in the background because you know the mathematics, right?
Yeah. There's always been a presumption. I mean, in thinking back to the Warfield literature, I think there's always been a presumption that there's a single interface to the matrix.
Right.
And the way that they used it to work with groups is they'd have the group vote, and if 7 out of 10 people voted yes, then they entered a single answer of yes.
Yes. Okay, I agree.
They managed a single point of interface, and I think when you even at that level, there's there were different ISM algorithms that were figuring out which is the question to ask next that'll give me the most inferential ability. And so that's one level that useful to be able to model the difference between the different. Excuse me a second.
Sure.
Hi, Ted. I'm good, but I'm on a conference call, so I'm going to call you right back. Okay, bye-bye. Um, so I don't think there's really kind of a model of the kind of the information gathering that's going on for different algorithms.
Okay, so yeah, there's tremendous information loss there when you do that. And that's one of the things that essentially what we want to do within our process is take that information and keep it in a database, and then those particular that information then would allow the generation of these parallel types of processes that are going on simultaneously with the main thread of inquiry that's going on when people are talking with a group. Again, that's something that we've sketched out. You've sketched out the the requirements for that. Thomas and I have worked up some of the SQL, basically database relational models that are required for that. And once this graphical interface with the JavaScript is put together, then the idea, of course, is to move that over and to put it into a system that has the database backend, collects all that data, and then with that data, you can essentially keep all these parallel things going on. But I think there's another more important aspect of this, and that's the fact that today we have much higher level computing power than the folks that actually started these algorithms, started looking at them. And so each time that we identify an area like you've identified, we think, oh, they take all this information, they bring it into a point, down to a yes or no answer, and then they just basically dispose of all that rich information they have about the voting and the group and all that. So
right. That's the type of thing I'm talking about, is the information modeling of that part of it. But once you develop the information model that is more at the interface of the inquiry, I think it also accommodates things like modal logic. For example, in temporal modal logic, the transitivity is not absolute. It deteriorates after several layers.
Right, and we've discussed those types of types of things.
The idea of modeling the information and uncertainty about each stage of inquiry you're going on would seem to also extend to inference in the face of uncertainty, as like if you have things that are sometimes before other things.
Right.
That transitivity propagates a little while, but it disappears after a couple layers. So
yeah, those are, and so these things that you're talking about now, that's one of the reasons that we're looking at the work of C.S. Peirce. In fact, one of the things that actually is working on this week, looking at a little bit, is his idea of continuity. And so his idea of continuity eliminates the law of the excluded middle for binary digital type of logic. It allows a fuzzy type of logic, and also because of the strength of the binding in a fuzzy type of continuity, that allows in my mind, the decay of any of the logical properties, like you're talking about the decay of the transitive property and so forth. I'm just not quite sure how you would put that function together or what the metrics would be, but I think I see how it would work. But there's a lot of stuff that, just a lot of infrastructure that needs to be put together before we get there. But these are all right on down the line.
I think that even the like the work in the early 80s that came out of Japan on fuzzy ISM.
Right.
They had fuzzy ways of entering assertions in the matrix,
Mm-hmm.
but they still didn't have a model of the difference between the information and uncertainty in people's heads and the information in the model and being propagated by the model.
Yes, and I also think that if I recollect correctly about the fuzzy ISM, that instead of just using the binary number system with Boolean operators, they used a fuzzy numbering system between 0 and 1 and Boolean operators.
Yeah.
And so what I'm suggesting is not only fuzzy numbering system or fuzzy values, but also fuzzy operators. And I think that takes it a little bit down a little bit different path. But actually, when you start releasing these constraints for vagueness, and that's basically what Peirce calls this area is vagueness, and we just don't know, right? And so how you would actually combine your symbol or marking system with your operating system, whether you have a vague marking system and a crisp, clean operator sets, or you have crisp, clean numbers and crisp, clean operator sets, or you have both fuzzy numbers and fuzzy operators. And those are things that I think are definitely important and will be necessary as we get closer to real answers. But I think we need, in my mind, for me to do this, I have to actually do, the crisp stuff first, understand that, right, and then understand why it's different. Because if I just wandered off and started doing things, I would kind of lose the connection. I don't know if that makes much sense. But.
Yeah, well, I mean, what I'm suggesting about an information model, there's still an information model about the difference between what's in people's heads, what's currently in the model, and the next step in the inquiry. There's something we don't really model that. I don't think anyone's modeled that before.
Well, I think that let's see.
It's just that if you do model it, I think it gives you a window into dealing with things like uncertainty and fuzzy logic.
Okay, but let's think about how we would address that, and I guess I'll think about that in the way that we've addressed it. And with information modeling, the standard Shannon information theory right now, you need to have a finite set of symbols. And so I'm kind of, that is kind of a constraint that's kind of worrisome to me. And so instead of looking at looking at Shannon's information theory and looking at the entropy and the information entropy, that's all kind of interesting, but what we look at mostly for triggering transitions are the boundary conditions. And those boundary conditions, basically the one that we find so far the most useful is that if you know the information before you get the message, then basically there is no information. And so we look at these models where there's a tremendous amount of redundant information that's being calculated again and again and again. And so we use that particular information model metric to now collapse or expand these models, but in a way of basically in an abstraction way. And so if you do that, then you can change the dimensions of the problem. And if you look at the inference and interconnection matrices that were done by Warfield, that gives you a structured way of combining different matrices that have common components. And so what you were talking about, a distributed ISM, that's kind of the way that I would see that some of the functions which you'd use to do that. You would actually use the interconnection matrices and the inference matrices to bring a large group of matrices together. But those would then, once you start to combine these, they would be very, very large. And of course, that was a little bit beyond the capability of the folks that developed these processes. So we have the computing power to do that now, and that's kind of one pathway forward. I think would probably be very fruitful to look at.
Yeah, I think another aspect that you kind of spurred an observation in me, but is that there's kind of this basic presumption that there was a lack of information before you model the structure, and that you're trying to elicit new information about the structure. But I think the reality in most cases is that you have a tremendous amount of conflicting information.
There you go.
Not that you're looking for information.
But you're trying to find the structure in all these different points of view, all these different symbol sets, all these different communication styles.
Right. And the way they came up with the facilitation is basically, a model where, we don't really know what's going on, and then we have a discussion about it, and then we vote and come up with the answer.
Right.
That's one, that's their basic presumptive model, is that people we're trying to find information like a query, and then we answer it. But I think something that's closer to reality is that there's too much information and it's conflicting, and we don't really have a different model of that aspect of it.
Well, the Peirce's model of the interpreter, you have the sign, the interpreter, and when you get into looking at those components, I think that there's actually is a model there. It's not clearly understood. But again, that's a little bit further down the road from what we're looking at here. But we're looking along those lines. But each person is an interpreter, and what's happening within the group abduction process is they're normalizing their experience so that they can have more of a real, at least conceptually think about it as a group interpreter. If I have 50 people that are 50 individual interpreters, then I bring them together into the observatorium, I go through these processes with them, they have these experiences together. Then I don't have 50 different interpreters. I actually have a group that can be viewed as an interpreter, but and it's a combination of all these different points of view. And so that's kind of the general way that I'm going down this road right now. Of course, I have a long way to go on that road.
So maybe we need a Peircean semiotic model of the inquiry process.
Exactly. I couldn't have said it better myself. That's it. Yep. Well, we're getting close to the end of this one for this month. January, we're going to do our next one on first Saturday in January, and I'll hopefully have more working software. Hopefully I'll have a partially ordered set web thing available, and we'll see how it goes. Anybody have any last comments they'd like to make today? Seems like everybody's on mute. Okay, well, this has been very, very good. We'll hopefully have some more of the members of the group next week, next month, and we have to get through the holidays and see what kind of progress we can make in the spring. Take care. Have a good holiday.
Okay, Joe. When are you thinking of having the next one?
Well, it'd be the first Saturday of January. It's first Saturday of every month. So let me just pull up my calendar here to see what date that is. See, that is
January 2nd.
January 2nd.
Okay. Hangover should be done by then.
You what?
I said that my hangover should be done by then.
Okay, all right. Well, I'll try to also I'll keep information coming out and kind of keep people posted on the list, the agenda, and so forth.
We need a semiotician now for that other thing.
Well,
I mean, Perse is almost impossible to read. For me.
We're working with a Perse expert on this. So, and it's I have some ideas about what to do, but I've found some footholds. Maybe that's the best way to talk about it. I think we may be able to start some transitions. And the primary foothold is actually transitivity is a trinary relation. And so and now the semiotics of working with the group and how they change over time, you interpret it, it's going to be very interesting. And we'll just see how it goes.
Okay, Joe, thank you.
You're welcome. See you guys next month, I mean.